Okay, so today we're talking about harmonic motion, okay? Harmonic motion. Okay. What is harmonic motion? It is basically watching something move up and down over time. It comes from sound waves, right? The whole term does, okay? So, we're going to do harmonic motion. Let's take a look at the first thing, okay? So, a mass is suspended from a spring. The spring is compressed to a distance of 4 centimeters. Let's go ahead and draw a picture, okay? So in a sense, this is brought up to 4, okay? And then we're going to let it go, okay? So then it says the mass returns to its original position after 1/3 of a second. So let me go as far as scales. We'll go maybe 1/3, 2/3, 3/3, which is 1, okay? So it's going to be all the way up at 4, but then it's going to come back down to -4. Does that make sense? It's a spring. So it's going to go up, come through 0, all the way down to -4. So the spring, over time, should look something like this. Goes back to its original position, right? Goes back to its original position. Goes back to its original position. And goes on and on and on, okay? So, can we find an equation for this? Sure we can. I think it's a cosine. In fact, let me draw the graphs on the side. You have two choices. We can either call things a sine curve, but to be a sine curve, it's got to start at 0, 0. Or you can call it a cosine curve, which it is because it starts up and then rolls down. Okay, this is a cosine. So this is my sine, and this is my cosine. Okay. So I like to have the shapes of the graphs with me, so then I can take a look at them and decide which one it is. Definitely cosine, because you start up and go down, right? Definitely cosine. So let's start there. Let's go y equals something cosine, right? What's the amplitude? 4. Everybody agree? 4. I mean, it goes up 4, down 4. Now b. The b is, or the frequency is 2 pi divided by, well, it's got to be divided by the curve width, which is 1/3. Okay. Now, if you don't know how to do fractions, I do. I got you covered. So we're going to go 2 pi over 1 times 3 over 1, because I invert and multiply my fractions, okay? Rebecca, who are you looking for? There you go. Okay, can I have his note?
Yeah, where did he go?
When Lane left, maybe he left.
I don't know, he said he was hot.
Alright. Oh, there's Levi. You got a note that says go to Commons. Now, so B, or the frequency, is 6 pi, okay?
Wait, so how'd you get the...
Okay, so what I did is I took 2 pi, always 2 pi, right? And I divided it by the curve width. So I got 2 pi divided by 1/3. I invert and multiply, right? So I'm going to go 6 pi. Since I started right on the money, it's going to be 6 pi, and then there's going to be no horizontal shift, and there's no vertical shift. So that is the equation, okay? Yeah. Yeah, I've got the t right there. Yeah. Is that pretty easy? Okay. B, graph this equation over 1 second. I just did, so I can do it again real quick. There's 1/3, 2/3, 3/3, right? I like to go all 4 squares. I think you guys have seen why I like to go 4 squares, right? 4, -4. There's 1/3 of a second. 2/3 of a second. 3/3 of a second, and so far and so on. So where is the position after 1 second? Well, we can see it, can't we? Am I going too fast? Maybe. Maybe. Okay, now, at 1 second, where is it? Well, it's exactly right here. We know it's at what? A height of 4. You agree with that? So it's going to be at 4 centimeters. Now, sometimes it's not easy. What if I ask for like 1.75 seconds? Or what if I asked for 1.8 seconds? Well, if we could use our calculator, I'll show you how we can do this, okay? So what we could do is put it in y equals, oh, I don't want y equals, clear, quit. So I could take my 4 cosine, and I could go my 6 pi times 1, right? So if I just plug in my 1 second, I should get the height, and it's 4. Now we already knew it was 4, but why would we bother? Well, what if I wanted to know where it was at, say, 1.3 seconds? Well, it's not so easy to find out where 1.3 seconds is, but I could do plug in time, right? That's all I'm doing is plug in time. 4 cosine 6 pi times, say, 1.3 seconds, right? Be a height of 3.26. So all you do is just plug the time into your equation. You can find any corresponding height, right? It's not hard. How am I doing, okay? Pretty simple. We're getting good at graphs, aren't we? Because we just keep going over them, okay? Turn the page, okay? All right, now here's kind of a bizarre question. We're actually, now Lane's gone, but where's Lane when it comes to these questions, all right? So, back to the Earth. Check it out. Now, where's my sunshine? Here's my sunshine, okay? Now, the problem is, when it's summer for these guys, they get a lot of sun. Do you agree? And we don't get very much sun. So it turns out that in the wintertime, we get really short days, don't we? Yeah. And in the summertime, you get really long days. It makes sense because of the exposure. Which way, right? Does that make sense? Right? We're not getting much sun up here at all, okay? So what happens is that over a year, an entire year, you get either really short days or really long days, okay? So let's go ahead and take a look at some of the things we have. Okay, so first of all, I have a latitude of 40 degrees. Now 40 degrees, we're about 48 degrees. Does that make sense? Washington, I would bet the Washington-Oregon border is pretty close to 40 degrees. That'd be my guess. So if you maybe lived in Portland, you're probably close to about 40 degrees latitude. So they're going to get a wee bit more sun than we are in the wintertime. Same thing with California. California gets a wee bit more sun. In fact, if you ever fly down to California in the wintertime, it doesn't get dark as early as it does here. However, if you fly down to California in the summertime, we get a lot more sun. It's like it doesn't get dark till 10, right? But if you're down in California, it might still get dark at 8 because you're closer to the equator, okay? So let's do a little dot to dot, okay? It says the longest day has 14 hours and 50 minutes of daylight, and the shortest day is 9 hours and 10 minutes, okay? Find a function to model. So first of all, before we do anything, let's try and do a little graph, okay? So let's start right here, okay? Here we are, January 1st, okay? January 1st. And what I need to do is go entire 12 months. Let me count my squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So I'm probably going to have to break this into every 2 squares to be a month. So January, let's make this February, March, April, right? You guys with me? May, yeah. Okay. June, don't worry about it. We'll see ya. July, August, right? September, October, November, December, and we'd be right back to January 1st there. So I went every 2 squares. That makes sense? Okay, I went every 2 squares. And so the longest day of the year, when is that?
April.
No, isn't it July 12th?
Oh my goodness. Such a hard job. Really? Come on, you guys. When's the longest day of the year?
January 1st. June 20th. You don't get caught.
Thank you. How about June 21st? It's the summer solstice. This is summer solstice. This is June. We'll go 21 because normally it's 21, Duncan, but it fluctuates, right? Yeah. Thank you. June 21st is our longest day. Yeah, it really is. In fact, what happens is if you think about it, one more time, a little bit of science. I just love science, okay? So, right about here is June 21st. And as it moves, this, you get a little less sun, right? So June 21st is the equinox, okay? When's our shortest day? When's the shortest day?
Winter.
Winter, yeah, so that's the longest.
25th, 27th.
No,
22nd.
22nd.
December 21st, normally. Now, what I say because it has with rotation of the Earth, so sometimes it's the 20th, 21st, or 22nd, right, Duncan? Depends on the year, okay? But most of the time it's the 21st of June. So the longest day is going to have 14 hours and 50 minutes. And the shortest day is going to have 9 hours and 10 minutes. How am I doing? Okay? How am I doing? So far, so good? I'm going to change these to decimals. It's going to help me. 14 and 50 sixtieths, which is 14.
Wait, the whole day lasts for 14 hours?
Yeah. I mean, even longer for us. June 21st. Remember how it's like light out till 10 o'clock in the morning in June, right?
Till 10 o'clock in the morning?
No, at night. I'm sorry. 10 o'clock at night. Right? June, remember June, man, it's nice. It's like 10 o'clock at night.
Stay up the whole day.
And then if you were to, and then it probably rises. Now here's something cool. If you were way up in Alaska, June 21st, the sun will not set. The sun will not set. If you're at the North Pole, the sun will not set at all. But in the wintertime, the sun will not rise. Okay, 50 divided by 60. So this is the same thing as a 14.83, okay? Now, shortest day. December 21st, as a decimal, it's 9 and 10 50ths, which is 9.16.
50th, so that'd be 60.
There you go. So let's make a graph, all right?
60. 10. You're 9.
60ths, yeah.
Do your.
Yeah, and I did the right calculations. Okay, so 14, let's do it. So in my graph, I'm going to go 5, 10, 15, okay? You with me? So June 21st, let's find it. June 21st is about here. Let's go to 14.8, so about there. December 21st is about here. Let's go to about 9. Okay, it's right about there. Okay. The other December 21st would be about 9 also. So our graph should look something like this. Something like this, okay? For daylight, the amount of daylight over a year in Portland, okay? So how about the equation? Yeah, so this is the amount. So every day from here on out until June 21st, the days are going to get longer, aren't they? You guys agree? Every day from here on out, the days get longer. You guys agree? When you hit June 21st, the height of summer, the days will start getting shorter again until you get to December 21st, and then the days will start to get longer again, right?
How come you're starting at 10?
It's back down a bit. It's below 9. It's 9.16.
Oh.
Yeah, but I'm going back to December, okay?
May 10th.
May 10th, right? So we'll find out May 10th in a second. Let's get an equation first, okay? So let's come up with an equation. So I would call it a cosine, because I can go right there. So let's go y equals a cosine, right? How do we find our amplitude? What's our amplitude? So our amplitude is going to be a 14.83 minus my 9.16 divided by 2, right? So 14.83 minus 9.16 and divide that by 2. So my amplitude is about 2.8, okay?
Can you your paper, please?
Yes.
Thank you.
No, I appreciate it. Thank you for saying it so nicely, too. Appreciate it. That was nice of you. So I found my amplitude. I went max minus my min divided by 2, okay? Now, B. We got to find B. So to find B, we're going to find B by 2 pi divided by the curve width. Okay, now this is the most amazing, easiest question of all, but you're going to overthink it. What is the curve width?
360.
What?
Say it again.
360.
5.
5.
365. Why is it
Because
365?
that's a year.
That's a year, right? Right? Nice job. Trust me, a lot of you are sitting there going, I don't know what the curve width is, but it's 365, right? It's got to be 365. So B is 2 pi divided by 365. So I'm going to go 2 pi over 365, parentheses, T. Now, we got to do a little bit of math. We got to do some counting, okay? We got to figure it out. So, June 21st, right? June 21st. How many days into the calendar year is June 21st? Okay, so let's do some math. So, January. How many days are in January? Come on, how many days are in 31? How many days are in February?
28.
28.
Unless it's a leap year, but we're not going to count a leap year, right? 28. How about March?
31.
And then April, we're only going to, nope, we got April, because 30. May,
30.
31. And then we're going to June
June.
21, because that's when we want, right? June 21? Right? You guys ever do this whole thing with the calendar?
That's
Yeah, I
what
like
I
it.
was doing.
Okay, so let's figure out how many days that is. All right, Claire, you guys watching? So I'm going to go 31 plus 28 plus 31 plus, I lost track, 30 plus 31 plus 21. So it's 172 days. So I'm going to go T minus 172, okay? Now, Elijah? No, Carmen. Can I ask Carmen? Carmen? Thank you. Where did, okay, real quick, where did this 172 come from? Where did the 172 come from? Those who are paying attention might know.
Days within June 21st.
Nice. It is the days from January 1 to June 21st are 172 days, and that's what our shift is, right? Okay, plus let's get this value here, plus, so the whole graph's been shifted up, right? How much? Well, to get K, take your minimum, and our minimum is our 9.16 plus our amplitude, which is 2.8. If I add those together, real quick, I go 9.16 plus 2.8, and I get an answer of about 11.96. We'll say 12, okay, plus 12, okay? There's our equation, all right? Now, what if we want to find out how much daylight's at May 10th? Well, we're going to plug 10 in, right? But we're not going to plug 10 in because we got to find out what day in the year is May 10th, right? What day of the year is May 10th? So May 10th, let's do it again. January is 31, right? February is 28. March has 31 days in it. April has got 30 days in it. And then we want May 10th, so we're going to go 10 days. So let's add all those numbers up, okay? So how many days in the calendar is to May 10th? All right, I don't know. Let's I add them all up, okay? All right. Thank you. 130. So I'm going to plug 130 into my equation. 130 what? Did you get a different number? It's 132. I'm going to do it real quick. 31 plus 28 plus 31 plus 30 plus 10. I got 130 also. Okay, there you go. So let's take 130 and plug it into my equation, right? So let's do it. So I'm going to go, all right, I'm going to go 2.8 cosine parentheses 2 pi divided by 365 times my 130 minus my 172, and then I'm going to go and add 12 and get an answer of about 14.1 hours of daylight on my birthday. There you go. Not bad. So I got about 14.1
On your birthday?
hours on my birthday of daylight. All right. Here is our homework. I'll help you with it if you need help.